again, and we are still working on section 6.3. I don't want to do a lot of it because that's homework for tonight. So section 6.3 is what is here, and we can. So let's see this question. Write the given statement in an equivalent logarithmic form. And by the way, now what we want to do, we have already had enough that the exponential function and logarithmic functions are emphasis of each other. So we already wrote that 8 is the same as 2 to the power 3. And if I want to change this to logarithmic form, I will say log of 8 to base 2 is equal to 3. All right. So the base of the exponential function is also the base of the logarithmic function. The exponent of the exponential function is the right-hand side. The number here is called the argument. The argument cannot be less than 0. It cannot be 0. And it cannot be less than 0. Even if it's 0, it's okay. It cannot be less than 0. It cannot be negative. Okay, so now write the given statement in equivalent logarithmic form. Let's see. Let's start from number 1. So we are now in section 6.3. We have 6 sections in this chapter. This unit 3 is chapter 6 only. There are 6 sections. We're in 6.3 now. The most important sections are 6.5 and 6.6. I don't think we have 6.4. Okay. So if I'm told to change this function, this exponential function, to logarithmic function, I will say log to base 2, because the base of the exponential function is the same as the base of the logarithmic function of 32 is equal to 5, the exponent of the function. The log to the base of the exponential function and the logarithmic function are the same. The exponent is equal sign, and the logarithm, the argument is this. An argument cannot be less than 0. In other words, if it's an equation and you finish solving it, you have to check your answer, because the argument, if your answer gives you an argument of negative, then it is an extraneous solution. Okay, so let's change the next one. Okay, so this one says, write the given statement in an equivalent logarithmic form. So this is 1 over 5 to power 5 over 3 to power 3 is equal to 27 over 125. We are only told to write the given statement in the equivalent logarithmic form. So for me to rewrite it, I have to switch it around. So I will now write 3 over 5. If I want to, 3 over 5 to power 3 is equal to 27 is 3 to power 3. 125 is 5 to power 3. So is there a way I can get them to have the same base? Yes, they already have the same base. They already have the same base. Therefore, I see 3 over 5 to power 3 is equal to 3 over 5 to power 3. Okay, that is the way we can rewrite it. Choose the correct answer. Okay, so did they say we have to put it in logarithmic form? Okay, write the given statement in an equivalent logarithmic form. So log to base 3 over 5 is equal to 3. It's the same as, so I can just say log to base 3 over 5 of 27 over 123. So let's write it. Let's do that. So they actually asked us to write it in logarithmic form. So let's write it in logarithmic form. Let's write it in logarithmic form. So what is the base? The base of the exponential function is 5 over 3. What is the argument? 27 over 125 is equal to -3. Okay, so that is the logarithmic form, and that is D. Okay, so let's speed up a little bit. Okay, look at number, this is 6.3, everybody. This is 6.3 homework for tonight. That will help a lot when you start. Okay, and after doing homework for tonight, I will actually get into practice tests. All right, so we have, for the statement below, write the equivalent statement in logarithmic form. Okay, I will write log of 10,000. The base of the exponential function is 100. Is equal to 2. This is another way of telling me or saying that if I square 100, I'll get 10,000. That's what. If I square 100, I get 10,000. That's 100 times 100 is 10,000. That's exactly that. Okay, enough of all this. I think we have done enough of that. Let's go to this one that has cube root. So let's rewrite this. Let's rewrite number 5, and then we will actually go to properties of logarithm. So I want to rewrite what I have here. So I have 81 is equal to √3 to power 8. If I wrote it in exponential form, and I can actually change it to square root form. So I have 3 to power 1/2 multiply 8. So if I multiply that, I have 81 is equal to 3 to power 4. Okay, so that is that. Let's see properties of logarithm. That's just what we're going to do now. There are very, very important properties of logarithm. But see, we're already looking into solving logarithmic equation. But before we solve logarithmic equation, we need to go to PowerPoint 3.3 and see the laws of logarithm. So PowerPoint 6.3, PowerPoint 6.3, and I just want to make sure that everybody knows where it is. The laws of logarithm is what, if you know that, you will not, you won't be making mistakes in solving the problem. So we will quickly go to the laws of logarithm, PowerPoint 6.3. Okay, so let me get 6.3. I think it might be 6.4, but let's see. Is it at 6.3? Let's see the laws of logarithm. We're looking for the laws of logarithm. That's what. Okay, they're right here. Properties. Well, some books call it law. Some books call it properties. But let's start because this is important. I want us to look at it because this is very, very important. The properties of logarithm, you must know it until you finish all the classes. These properties are going to be there in your calculus class, Math 140, Math 130, Math 230, Math 241, whatever you're doing. And if you remember it now, you know it now, that would be very good. Okay. So, or these are just exponents, or you can just the same thing with exponential function. The base of an exponential function and logarithmic function cannot be negative. The base cannot be negative. Also, the base cannot be equal to 1. Just like an exponential function. For logarithmic function, the base cannot be less than 1, cannot be negative. And the base cannot be equal to 1. Okay. Anyway, for this one, this is number 1, property number 1. Property number 1 says log of 1 to base a is equal to 0. Is it true? Let's check it out. We already know this. So how we're going to check it is we convert it back to exponential function. So let's convert this back to exponential function. 1 is equal to base raised to the power 0. Any number raised to the power 0 is 1. Therefore, 1 is equal to 1. So it is true. So property number 1 is true. As much as we can, we try to prove it. If not, we memorize it. If there are some proofs that are outside our class, we memorize it. Okay, look at this one. It's saying number 2. Number 2 says if I have a number, well, suppose I have log of 10 to power x to base 10, and the answer is x. Yes, because very soon we will see that the exponent of logarithm is coefficient. Anyway, the log of a number to the base is equal to 1. Log of 10 to base 10 is equal to 1. By the way, now I want you to, let's go to calculator. Go to a calculator and turn on. By the way, where is this log? Look at this log. So I want you to press log in your calculator. Log. And put 10 there. Log 10. Log 10 is equal to 1. The reason why it is 1 is that the base is 1. And by the way, our calculator TI-84 and TI-83, they don't understand any other base except base 10. It's called common logarithm or natural log. So we're coming to natural log. Okay, so log of any number to base 10, log of 10 to base 10 is 1. Also, I can now generalize and say log of n to base n is equal to 1. Log of 5 to base 5 is equal to 1. Okay, log of any number to its base is 1. Okay, that is, we already saw E before. Log of any number, let's call it x to base e, is called natural logarithm. We call it natural logarithm. So we call it natural log of x. So e, whenever log is written in base e, is called natural logarithm. Okay, by the way, let's continue. Property number 3 says, if the base, let's say that the base is 6 raised to power base 6 again, k, the answer is k. Base raised to log of the same base is k. Okay, so let's say 12 raised to log to base 12 of whatever number it is, m is equal to m. Okay, so let's go to the other. We want to know all the other rules. So there are 3 more rules right here. Let's go over them. Rule number 4, even though it's not called, they're not in order. So rule number 4 is called the product rule. Product. For x greater than 0, which you will already know, and because the argument must be greater than 0 and y greater than 0, there's no way the argument can be less than 0. And the base greater than 0, base must be greater than 0. base cannot be, and a, the base cannot be 1. See, we already know this. The argument of a logarithm cannot be negative, so x times y must be positive. This must be positive. The base must be positive, and the base cannot be equal to 1. So this we already know. All right, so I know I've said it several times. So I know why I'm saying it, so that you will not get the value of x to be negative. You know, it's an extraneous solution. So sometimes whenever you get the value, you check your value, check the value. All right, for now, suppose I'm talking about 12. Let's talk about 12. And let's talk about the base. Maybe let's just talk about base A. Log of 12 to base A, let's call it base A. I can rewrite it as log of 3 times 4 to base A, yeah. So I'll find the factors of, and then I can write it 3 times 2 times 2, which implies that I can say log of 3 to base A plus multiplication is addition in logarithm, plus log of 4 to base A. If I can break it into other pieces, I can break it on other pieces too. So multiplication is addition, provided that x and y are positive, the base is greater than 1. Okay, we're going to see more questions on this. If I have 24, or if I have 22, okay, so I say log of 22 to be any base, let's say base B, I can rewrite it as log of 2 to base B plus log of 11 to base B, because 2 times 11 is 22. So if I'm multiplying, I can add. So the product rule says multiplication can be used as addition. So the next one is quotient rule. We call next rule, we call the rule number 5. Quotient rule. All right, quotient rule. If I have a number, so suppose I have log of 3 divided by 4 to base B or A. Let's not just worry about the base now. We're going to just assume that the A cannot be equal to 1. It's equal to, because it is quotient rule means division in logarithm. The rules of logarithm says if you are dividing, you subtract. So I will say log of 3 to base A minus log of 4 to base A. So I can rewrite it like that. We're going to see some questions now. Power rule in logarithm says that exponent can be coefficient. Exponent can be coefficient. So exponent can be coefficient. And so if I have log of 3 to power 2 to base A, I can rewrite it as 2 log 3 to base A. Okay, so let's find questions. Let's find questions on this PowerPoint. All right, so we're going to find questions that are going to show us. So quickly, we are going to we're going to practice test 6.3 and get, homework, not just homework. 6.3 is where we are now. So application of logarithm is what we're doing now. Application of logarithm. So let's go ahead and solve the problem. Solve the equation. We can solve the logarithmic equation. Let's keep on solving the logarithmic equation. But now we need to remember that we have laws also. We have laws also. So let's first rewrite this. Remember, this is your homework, so I'm not about to do all of them. So 7 to power 12 is equal to x to power 24. Is there a way we can when you see this kind of question, we want to see if is there any way we can rewrite it in the solved equation, give an exact solution. So this time we are solving for x. So first of all, we change it to exponential form, and then we can find the factors. So x to power 24 is equal to 7 to power 12. And then you can put this in your calculator. Take the 24 root of both sides, because at this point, it did not say solve with, it didn't say without using calculator. Okay, type an exact answer using radicals as needed. So I'm going to use radical 24 right here. Find the 24 root on both sides. So this will go with that. So I have x is equal to 7, 12 over 24. 12 over 24 is 1/2. So x is equal to 7, 1/2. Another way of writing this is square root of 7. So my answer will end up being square root of 7. Okay. So you can now go ahead and solve. Let's see application of a logarithm. Everybody look, this is one of the laws of logarithm. Whenever the base is equal to the base of the logarithm, your answer is 1 right here. Find the indicated value here. Log 1 to base 3 is 1. Log 1 to anything, you can put it in your calculator, but log 1 is 1. Simplify the expression. So you can, sometimes you're told to simplify with calculator sometimes. Everybody look, natural log of E to power 8 over 9. I want us to know that, remember that natural log of E is 1. So according to the laws of exponent, exponent is equal to coefficient, then natural log of E. And natural log of E is 1. And by the way, remember that natural log of E is the same as log E to base E. Log of any number to the base is 1. So natural log of E is 1. So therefore, so anytime you see natural log of E, it is 1. And so the answer here is 8 over 9. All right, so like this one too, you will be able to solve that. And so you already use a calculator to find this. So you just put this, whenever there's no log there, then the base is 10. If you're not given the base, then the base is 10. Like here. So number 19, if I'm told to solve that, I'll get my calculator. Because there is no base, I will just put it in my calculator. So go to log, and what is that number there? 0.121, 0.121, log of 0.121. When I hit enter, the answer is negative. The answer is leave your answer to 4 decimal places. Okay, so we found the log to be negative 0.929. Okay, use calculator. Natural log. Let's find where natural log is. Where is natural log? Let me see. Where is my calculator? My calculator disappeared. Okay, I'll go get it again. I'll go get my calculator. All right, so go back, get my calculator, and All right, so now I am going to answer the question, natural log of 77. So everybody see, whenever the question says natural log, you come over here, ln. Natural log is ln. In other words, log to base e of 77. So 77, close parenthesis, that's it. You enter. It's not that bad. Uh-oh, we have only 5 minutes remaining. All right, so let's see. Let's see, you can use calculator to answer a lot of questions, so that next class, all we're going to do next class will be expressed as a sum. So we're going to do just number 25. We've got 4 minutes. Let's do 25. So we're going to now express as a sum or difference. In other words, apply the laws of logarithm. Division is subtraction. So log to base 5 of 33 minus log to base 9, log 19 to base 5. That's it. It's just simple like that, because we already know the laws of logarithm. Number 26, the numerator is multiplication. So we have one denominator. So let's go. Log to base 3 of that numerator, 5 plus log to base 3 of y minus log to base 3 of z. So numerator is multiplication, denominator. That's application of logarithm, laws of logarithm. Because the laws of logarithm says multiplication is addition, division is subtraction, and so on. We got time to also do, we have time to do this, use the properties of logarithm. So when next we come here, that's Thursday, we shall be doing applications of logarithm. Applications. So now we know the laws of logarithm, the laws of exponent. We know the inverse properties of logarithms. We know how to convert. We know the basics so far. So now we shall be able to answer the question. All right. I want everybody to know that there is no law of logarithm that says addition. It says multiplication is addition. It did not say addition. So they actually want to see if this cannot be simplified. There is nothing to simplify here, because the law of logarithm does not include addition. It says multiplication is addition. It did not say addition is multiplication. So be careful. The reverse is not the case. Somebody just gave you something to confuse you. You don't want to be confused. It's only multiplication is addition. It did not say addition is multiplication. The converse is not true in the laws of logarithm. One last one. How many minutes do we have? 2 minutes. We got 2 minutes. Okay. We can rewrite this. So let's do that. The numerator says all the multiplications there, all of them to base b. So we can say log to base b of all the numerator, x log b, plus, remember that exponent is coefficient 3 log y, because exponent is coefficient, minus 3 log z. So that is exponent is coefficient. So you just know the multiplication and the numerator, division, so you can apply all of them, the laws of logarithm. So next class, Thursday, will be application of logarithm. Any questions? If you already missed one test, you cannot miss another test. If you miss another test, it will be 0. Final exam will make up one missed test, but it will not make up more than one. So if you already missed a test, please don't miss another one.